So let's go over the sections about angles and the trigonometric functions. First example here is a 37-foot ladder is leaning against the side of a building. If the ladder makes an angle of 31 degrees, 15 minutes with the side of the building, how far up from the ground does the ladder contact the building? And round your answer to the nearest hundreds if possible. So it's always good if we can draw a picture. So I'm going to draw this building and whoops, the ground. Let's see if I can't get that a little neater. All right, and then I got this ladder leaning against it, and we want to know this height right here. We got the angle, right? Okay, so let's talk about this. We need to convert the degrees in minutes to all degrees, so that way we can put it into our identity. So I have 30 degrees, 15 minutes. Well, we know that for every 1 degree, it's 60 minutes. So now I'm going to do a simple conversion. I got 31 degrees plus 15 minutes over 60 minutes times that 1 degrees. That gives me 31 degrees plus, and I'm going to reduce this fraction here. It reduces by 15. 15 goes into itself once, and it goes into 64 times. So now I got 1/4 degrees, which can be rewritten in decimal form because it will give us a clean decimal. So I got 31 degrees plus 0.25 degrees. And let's put it together. It gives me 31.25 degrees. So good. Now I got an angle in the format that it's all in a like term, right? It's not degrees, minutes, it's degrees. So now let's use our cosine of some angle is equal to our height over x. Well, our height here is what we're looking for. My 37-foot ladder is going to be my x value, and we know our angle, so let's just rewrite it again. Cosine of 31.25 degrees is equal to my height over 37. I want to get h by itself, the height by itself, because that's what I'm solving for. So I'm going to multiply each side by 37 because it's in the denominator, and we need to undo that fraction to get h by itself, isolate h. So now I'm going to rewrite this in a format where it's h is equal to that 37 cosine 31.25 degrees. Make sure your calculator is in degrees mode. And let's round to the nearest hundred. So we're going to have approximately 31.63 feet. That's how high up the ladder is going against the wall. Okay. So let's do our next example. Our next example says convert the 32 degrees, 4 minutes, and 25 seconds to all degrees. And we're going to round to the 4 decimal places, which is the 10,000. So let's do this. So I already see that I got the 32 degrees, right? But let's do the 4 minutes. We know that in 1 degree, it's 60 minutes. And then we got the 25 seconds over. Well, in 1 degree, that's 3,600 seconds. So now we have 32 degrees plus, and let's reduce this fraction. 4 goes in itself once, goes in 60, 15 times, and of course the minutes reduce down, right? Let's do the 25 goes in itself once and goes into 3,600. I'm gonna double check. We're just gonna make sure. 3,600 divides, I would say 144. Yes, 144. All right, and of course the seconds reduce out. So now I have 1/15 degree plus I have 1/44, 1/144 degrees. So alpha is going to give me, and we're going to round, so I'm going to have approximation. Right now it's equal to, but when we put it all together, it's going to be approximation. Plus I have that 1/15 gives me, gives me a yucky looking decimal. So let's add it all together, okay? Since it gives me a yucky looking decimal, let's just put it all together in the same. So I get 32 plus that 1/15, because you don't want to round too soon, because it can make you be off by 10,000ths of a point or hundredths of a point, so just be careful. So now I have 32.0736 degrees. And that is my answer. So yes, we need to make this approximation. Okay. So now let's go to our next example. Our next example says we have negative 18.534 degrees. It says convert it to degrees, minutes, seconds. So knowing that the number in front of the decimal already gave me my degrees, so I'm going to come over here for my answer section. And I'm going to go ahead and say 18 degrees. But don't forget, it's got a negative on it, so I'm going to put the negative with it. Now let's focus at the decimal. The decimal part's what we're going to use to convert. So this is in degrees. I know that in 1 degree, it's 60 minutes. So the degrees reduce down, leaves me 0.534 times 60. That gives me 32.04 minutes. So the number in front of the decimal is going to be my minutes. We're going to focus on the number behind the decimal. And let's solve for it. We know that in 1 minute, we get 60 seconds. And I should have kept the notation. Let's keep the notation the same. All right, so the minutes reduced leaves me a 0.04 times that 60. And it gives me 2.4 seconds. The number in front of us is what we're going to work with, but we look behind the decimal. Does that number cause that 2 to round up or stay the same? Since it's less than 5, I'm going to say it leaves it alone, and that is my answer. Negative 18 degrees, 32 minutes, and 2 seconds. Okay, let's do our next example. Our next example now says that you are giving this triangle with degrees on it, and the degrees in minutes. It says find the measure of the angle alpha. So we're looking for the third measure. So what we're going to do is let's take this here, 83 degrees, 43 minutes. Let's add it to the 30 degrees, 46 minutes, plus this alpha. And we know when we're talking about a triangle, it all equals 180 degrees. Guys, in order to add or subtract, you have to have like terms. And if you notice, we have a degree, and we have a minute and a minute. So these are like terms. We can put them together. So I got 83 plus 30, and that's going to be degrees. I got 43 plus 46, and that's going to be minutes. All plus this alpha equals 180 degrees. Now, 83 plus 30 gives me 113 degrees. The 43 plus 46 gives me the 89 minutes added to alpha equals 180 degrees. Okay. Get the alpha isolated, get it by itself. In order to do that, that means I need to subtract this 113 degrees, 89 minutes from the 180 degrees. Here's the thing. Again, we got, in order to add or subtract, they have to be like terms. And if you notice, I got this in just degrees. This is degrees in minutes. So these are not like terms. So let's rewrite 180 degrees in a format that makes it like term. and still keeps it true to 180 degrees. So I know that I can write 179 degrees. I know that in 1 degree it's 60 minutes. So knowing this, I can say 179 degrees, 60 minutes. That is true to 180 degrees. Now I can say, oh, okay, I can subtract it from this. And now let's do that. Let's put our degrees together and our minutes together using the correct operation. And I'm meaning to put that on the outside of the parentheses. All right. So 179 minus 113 gives me 66 degrees. 60 minus that 89 gives me a negative 29 degrees, or excuse me, minutes. And you would not say it in this format. You wouldn't want to say negative 29. The notation is not clean. So let's clean it up. So knowing this, I know I can take 1 degree from the 66, right? And here, I'm going to not skip that step. Let's show that step. I can say 66 minus 1 degrees, right? If I did that, then I can turn around and say, well, I can't ignore that degree that I'm subtracting out, but I can put it with the 29 degrees. I can add it to it, not degrees. I apologize, guys. I keep saying degrees. The negative 29 minutes, I can add it to that 60 minutes. There we go. Now I got 65 degrees and 31 minutes. That is my answer. Okay, I'll give you a minute and then we're going to move on to the next one. We're going to convert the following degree measures to radians. Okay, so what do we know? We know that pi equals 180 degrees. Yeah, because if we go to the unit circle, we have pi here. We also have 180 degrees. We have 2 pi here, and we have 360 degrees, right? You can use the 360 degree ratio with the 2 pi, but it's still going to reduce down, give us back the pi 180. So let's solve it. We got our 45 degrees. We're going to multiply that to pi over 180 degrees. My degrees reduce. Leaves me with 45 pi over 180. Let's reduce that 45, 180. And when we do that, we get 45 goes into itself once. And goes into 180 4 times. So now I got 1 times pi over 4, and that's my answer. And you may see some notation. It says radian, rad on it. You can write that. You don't have to always have it. But just make sure and read the directions. It may ask for it. You don't want to get it wrong just because of that. Okay, our next one says we have 21 pi over 20. And let's put it in degrees. So again, we know that 180 degrees over pi. So the pi is reduced, right? Now I'm left with 21 times that 180 degrees all over 20. And we can reduce, right? I know that 180 divided by 20 will reduce by 9. So 20 goes into itself once, 189 times. And that leaves me 21 times 9, which gives me 189 degrees. And that's my answer. Okay. Let's do our next one. All right. It says, find the length of the arc intercepted by the following central angle in a circle with the given radius of alpha is equal to 54 degrees and the radius of 20 miles. All right, so when we go back to our arc intercept formula, we have S is equal to alpha times R. So again, just a reminder, we got 1 degree is equal to pi over 180 degrees. So I can take that 54 degrees and multiply it by pi over 180 degrees. It's going to reduce the degrees, leave me with 54 pi over 180 degrees. And let's divide that. 54 divides 180. Let's see if it reduces. It does. 54 reduces by 18 times 3, right? And 18 goes into 180 10 times. And you don't have to do it this way. I like to reduce. So I reduced my 18s. Now I got 3 pi tenths. So now that I have this part, I can plug it in. So my S is equal to 3 pi tenths times that R, which is 20. And what happens, if you want to, you can put a 1 over 20 and reduce the 10 and 20. And I'm left with 6 pi miles. Just be sure and read the directions. It may ask for it in decimal form. If it does, read what it asks you to round to. And I'm going to round to the nearest hundreds. So I got approximately 18.85 miles. So just depending on what it asks for on which one of these answers are, how you're going to respond back. So just make sure and read. All right, so now let's talk about the next one. It says we're going to convert 35 revolutions per minute to radians per minute. Okay, so what I know is 1 revolution is equal to 2 pi. And you can write radians with it if you need to. So I'm going to take my 35 revs over minutes, and I'm going to multiply that by 2 pi over rev, 1 rev. So now I'm able to reduce those out, and I'm left with the radians per minute. And it gives me 35 times 2, which is 70. 70 pi. Now, again, if it asks you to put it in decimal form and round to the nearest hundreds, then we can say, okay, let's see, 70 times pi. 200, let's round to the nearest tens. 219.9. This be radians per minute. This is radians per minute. So it just depends on how it asks you to write your answer out. Okay, so now let's do our next one. Okay, here's an application problem. It says a windmill for generating electricity has a blade that is 40 foot long. Depending on the wind, it rotates at various velocities. Find the angular velocity in radians per second for the tip of the blade if the windmill is rotating at a rate of 29,724 revs per day. The angular velocity for the tip of the blade is approximately blank radians per second. So we are going to use the formula. It's like a cursive looking W. And we're going to take our 29,724 revs per day. And I'm going to convert that to radians per second. So what do I know? All right. I know in 1 day, that's 24 hours. I know in 1 hour, that's 300 or excuse me, 3,600 seconds. And now let's convert the revs to radians. I know that for every 1 rev, that is 2 pi radians. All right, let's go through here. Let's mark out what we can. My day marks out, my hour marks out, my revs mark out, and I'm left with radians per second. That's what we wanted. All right, so now let's mark, well, I'm gonna just clean it up just for a second. All right, so I cleaned this up. Not all of you need this extra step, but those that do, I wanted you to see it. All right, finish up. I'm going to leave it in the exact form, and then I'm going to convert it to decimal, just in case. So the exact form, let's see, what? 29,724 times 2 over 24 times 3,600. That is, well, so it's not going to be exact. It's got a long decimal. So I'm going to say approximately this pi. And so let's times that by pi and round to the nearest tenths. All right. So when I round to the nearest tenths, I get 2.2 radians per second. Okay, so, all right. Let's move to our next one. Oops, too far. Assume that the alpha is an angle in standard position whose terminal sides contains points 4, 3. Find the exact values of the following functions. All right, so it's going to give you a list of functions we want to find. And what are they? It's going to be sine of the alpha. Let me just write them up here. That way I don't want to take up all my space. We're going to find sine alpha, cosine alpha, tangent alpha, cotangent alpha, secant alpha, and cosecant alpha. All right, so what we don't know is, and let me do just a quick reminder. We know that we have a squared plus b squared is equal to c squared. C squared is the longest side, where we get c is equal to the square root of a squared plus b squared. We know this. Now we're just changing the notation up a little bit, and we're calling it r is equal to x, the square root of x squared plus y squared. Still using the same method, same concept. We're just plugging in some, we're just changing a little bit of the notation. So what is r? Well, we know that x is 4, and let's square it, plus y is 3, let's square it. Now I have the square root of 16 plus 9, which is square root of 25, which is 5. All right, so now let's solve. We got sine of alpha is equal to y over r, right? Opposite over hypotenuse, the longest side is r. Let's plug in. My y is 3. I got it from this coordinate here. Over r, which is 5. Can't reduce it. It's in good notation, so we're going to leave it alone. I'm going to do and now in the software, it might not ask you to do it in the specific order, but I'm going to do this over here. I'm going to say, oh, okay, well, since I know this, I know that cosecant of alpha is sine inverse, right? So if I do this, I'm going to do extra steps. Y'all don't have to do it. I'm going to rewrite it. And this tells me I'm going to keep, oops, wrong spot, right here. Keep the first, change the operation, flip the second. When I do that, now I got 1 times that 5/3, which is 5/3. So if you notice it was the reciprocal, then you could just flip it. So we have what cosecant is and sine is. Let's find cosine. Cosine is x value over r, which is adjacent over the longest side. My x value here is 4. And my r is 5. So we can't do any more of the work. It's cleaned up. It's as far as it's going to go. So let's plug it into secant. We know it's the inverse of that. I'm going to do the extra steps, but again, guys, some of you may already see it and don't need these extra steps. You know, it's just the reciprocal, then that's what I would do. So I got 1 over 4/5. Rewrite it as 1 divides 4/5. We're going to say, oh, okay, we are going to keep, change, flip. So now I have 1 times that 5/4, which is 5/4. So now we know secant and we know cosine. Let's find tangent. Tangent is y over x, which is sine over cosine. So y is 3 and x is 4. And again, I'm getting that from this order pair here. So there's no other work to do here. It's in simplest form. So what I'm going to do is go ahead and find my cotangent. We know it's the inverse of tangent, which is 1 divide, oops, let's plug it in. Oh, let me skip that step. Which is 1 over 3/4, which is 1 divides 3/4, which means we are going to keep, change, flip. So got 1 times 4/3, which is just 4/3. So now we know what cotangent and tangent is. Give me a second and then we'll move on. Okay, let's move on. This next one says, what if alpha is 5π6? And then they want to know for all 6 of the identities, what would that value be? So sine at 5π6, well, we can go the unit circle to find its exact value, or you can plug it in your calculator. I encourage you to already know the unit circle. We know it's 1/2. Cosine 5π6, go to the unit circle, or you get it from memory, gives me a negative square root 3/2. And then tangent at 5π6. Well, tangent is going to be sine over cosine. So let's rewrite it. 1/2 divides negative square root 3/2. Now I'm going to change this up just right quick. So now we're going to say, okay, we're going to keep, change, flip. Keep the first, change to multiplication, flip this one. Now what I notice is that 2 goes into 2 once, right? It goes into itself once. So it leaves me with 1 times -1 over 1 times square root of 3. However, we can't have the square root of 3 in the denominator. So I'm going to multiply by the conjugate, which is square root of 3. And now I have -1 times the square root of 3 over square root of 3 times square root of 3 is just 3. That is my answer. Okay. So now I'm going to say, okay, I want to come back to the sine value and I want to find the cosecant. because I know the cosecant is the inverse of sine. So let's say in 1 divides that half. Just rewrite it as 1 divides half. Keep, change, flip. So my answer is 2, right? Don't forget, keep, change, flip. Now let's do our cosine, which is secant, 5 pi 6, which is 1 over cosine, it's the reciprocal. So I got 1 divides that negative square root of 3 halves. Let's keep, change, flip. So I get 1 times that negative square root. Oops, flip it. Don't forget to flip it. 2, negative 2 over square root of 3. So I'm going to come right here. Now I get negative 2 over square root of 3, but we can't have the square root of 3 in the denominator. So I'm going to multiply by the conjugate, which is square root of 3. So now I have negative 2 square root of 3 over 3. And that would be my cosecant. Or no, my secant. We got our cosecant, which is the cosine. And we got our secant. There we go. Now, we have one left to do. We need to find cotangent. Well, we know what tangent is, so that's going to make it easier to find cotangent, right? Because cotangent is the inverse of tangent. So I have 1 over that negative square root of 3/3. Rewrite it. Keep, change, flip. So I have 1 times that negative 3 over square root of 3, which is negative 3 over square root of 3, but we can't have that as a final answer, so I'm going to multiply by the conjugate. So now I have, let's change this up, negative, well, let's write it in here, negative 3 square root of 3 over 3. Now let's reduce if possible, and I'll notice the 3's reduce and leaves me with negative square root of 3. That is a cotangent. Okay, let's do our next one. The next one says find the exact values for all 6 trigonometric functions for the angle in the right triangle shown. So I'm going to draw one for you, and then we're just going to solve for it. Let's see if we can insert some shapes right quick. It's fine. Here we go. Oops. Let's undo that. It's not a good. Shape. All right, good deal. Now we got it. All right, so let's call this side here. We don't know. We have this angle here drawn right. This would have been my 90-degree angle right here. Let's call this 7. It should have been 7 down here. I should do that better. Let me erase this right quick, guys. Thank you for bearing with me. Let's just draw it out. Okay, so I got my right angle here. Got this angle right here. I'm not sure what it is. This is 7, 3, and we don't know what that is. All right. We don't know what the hypotenuse is. So to find it, we're going to use the R equals the square root of x squared plus y squared. So what do I have for x? I have the 7, and the y, I have the 3. So now I have 49 plus 9. And 49 plus 9 is 58. So I have the square root of 58. So now the square root of 58 does not simplify any further. So we're going to leave it like that. So now that I've done that, I know that this hypotenuse side here is the square root of 58. So good deal. Now let's start finding all 6 trigonometric functions. So let's find sine first. Sine of the angle we know is going to be the opposite over hypotenuse. We also say it's y over r. So my y value is 3 and my r is square root of 58. Of course, our final answer can't have square root in the denominator, so I'm going to multiply by its conjugate. So now I have 3 square root of 58 over 58, and that is my final answer because it doesn't reduce. You can always try to see if 3 will go in 58, but it won't. But I mean, I encourage you to try. All right, so let's find cosine. Well, cosine is adjacent over hypotenuse, which is x over r. So x value here is 7 and r is square root of 58. And again, since, we can't have square root in denominator, we're going to clean it up by multiplying by its conjugate. So now I have 7 square root of 58 over 58. So there's my cosine. And you can double check, see if 7 goes into 58. And if it reduces, reduce. So now let's do our tangent. Our tangent, let's do this. Tangent of the alpha. Well, that's sine of alpha over cosine of alpha, right? We also can say, oh, well, that's the opposite over adjacent. So the opposite is 3, the adjacent is 7. So we got 3/7. That one was nice and easy. So we're done. So I'm going to go across here. Let's change this up to, let's do this. Let's find its reciprocal, right? If I find its reciprocal, I know it's cosecant of the angle, right? Because it's going to be 1 over that sine. So let's do this. I have 1 over 3 square root of 58 divided by 58. And guys, I'm going to just a little shorthand. I'm going to do this. I'm not saying you have to. Please don't do it this way if it's confusing. But we can also say it's the reciprocal, meaning that it's going to be hypotenuse over opposite. Do it that way. You could say it's 1 over sine of that angle. Whatever works for you. If you did that hypotenuse, we know we're just going to flip this. If you need to write it out this way, I would write it out the way that makes more sense to you. The shortcuts come later. So now doing that, I'm going to use my basic math, and I'm going to say 1 divides that 3 square root of 58 divided by 58. And I'm going to use my key change flip. So I got 1 times that 58 over 3 square root of 58. So now I get what? 58 over 3 square root of 58. And we can't have that in our end answer. So I'm going to have to multiply by the conjugate, which is square root of 58. When I do that, now I'm left with, let's change this again, 58, square root of 58, all over 3 times 58. And oh, this works out great. My 58's reduced, it goes into itself once. Now, my cosecant is going to be square root of 58 over 3. Okay, so let's find our secant. And if you need to, I would make boxes or something, something that where you keep the work from running in together. So my secant, let's see, let's change this to, let's go there. My secant, again, is going to be 1 over cosine of alpha. Let's split the page. Which is also seen as it's also seen as hypotenuse over adjacent. But I'm going to stick with what we've been doing. It's going to be 1 over my 7 square root of 58 divided by 58. I'm going to rewrite that as 1 divides 7 square root of 58 over 58. We're going to keep, change, flip. So now I got 1 times 58 over 7 square root of 58. I'm going to rewrite it, 58 over 7 square root. Okay, we have a rule. We can't have a root in the denominator. So I'm going to multiply that fraction by the conjugate, which is the square root of 58. So now I get 58 square root of 58 all over 7 times 58. And I can reduce the 58s because it's self once. And that leaves me with square root of 58 over 7. And that's my answer. And whenever we got so much going on the page, you can do this. That helps. That helps. Just change it up a little bit. Stick this one. Just trying to make it where it's not so much on the page you can't make out what part it is. Ooh, that's not it. No. Let's not use that. That was too dark. Let's use this one. There we go. We've got one more left. Let's find the cotangent. Cotangent is going to be the reciprocal of tangent, which means it's cosine over sine, which is adjacent over opposite, which is 1 over tangent. So let's plug in what we know. 1 over 3/7. Rewrite it. 1 divides 3/7. We're going to keep, change, flip. 1 times 7/3 is equal to 7/3. And let's just change that right quick. Yeah, it's not bad. There we go. So we got all 6 identities. Okay, so now let's solve our next one. And next one says solve the right triangle with B equal 1.65, C equals 4.72. Find alpha using the cosine function or beta using the sine function. So you got a choice here, right? So first thing is we need to find the Pythagorean theorem because I don't know what A is. So I know a squared plus b squared is equal to c squared. I know what b is, so let's subtract it from this side. So now I am looking for a squared is equal to c squared minus b squared. And let's take the square root of both sides so I can get a. So now I said a is equal to square root of c squared minus b squared. So what we're going to do is plug in what we know. So let's come over here and say a equals c is 4.72 and square it minus b, which is 1.65 squared. And let's figure that out. So, and you may want to round to the nearest hundreds on this. Just be careful on the rounding. You know, round too soon, it can cause us to be off by a number. So now I know what A is. So we know what all A, B, C is. So if you noticed, C is the longest side. So we set this up correctly. We did it right. A and B to add it together should equal C, right? Because the shorter sides should add up to equal the longest. So now let's use cosine of alpha, which we know is adjacent over hypotenuse. Adjacent is going to be the 1.65 over the hypotenuse, which is 4.72 in this one, okay? So we can, let's do one extra step. I don't want to put it in decimal form too soon because it can get messy. So what I want to do is solve for alpha by taking the inverse of cosine. All right, let's round to the nearest hundreds. So cosine inverse. Oops. Make sure we use our parentheses. If your calculator requires it. So make sure your calculator is in degrees mode. And I get approximately 69.54 degrees. Okay, so now I found that. Let's find out what beta is. So we know we take alpha plus beta plus gamma is equal to 180 degrees. We know this, right? However, all I know is alpha plus beta, so it's going to be equal to 90 degrees. I'm going to plug in for my alpha, but let's go ahead and subtract it from both sides first. So now I get beta is equal to 90 degrees minus my alpha, which we know is 90 degrees minus 69.54 is equal to 20.46 degrees for beta. So we know where our beta is. If you are asked to turn around and put it in sine of beta, then we know what that is as well. We could have solved, we could have done either or, but this is all it asked us to do. Okay. Let's see. So we have one more for this section. It says a weight is suspended on a vertical spring. The position X of the weight on the vertical number line is given as a function of, let me highlight it, X equals 2 sine t minus 8 cosine t. This is where t is time in seconds. Find the initial position when time is at 0. So I'm just going to plug in 0 for t. So when I plug in 0 for t, sine at 0, well, if you plug it in your calculator, if you're ever unsure, sine at 0 is just 0. Cosine, if you plug it in your calculator, if you're unsure, at 0 is 1. These are things you should know by now, but if you're, sometimes we get a little anxious or have anxiety when you take a test or do a homework assignment. Trust yourself, but you can always check your answer. 2 times 0 is 0, minus 8 times 1, which is 8. My end answer is -8. The next one said, what if time was 7 pi 4? So make sure your calculator is in radians. So I'm going to take x equals 2 sine of the 7 pi 4ths minus 8 cosine of 7 pi 4ths. And some of you may already know what sine of 7 pi 4ths and cosine of 7 pi 4ths is because of the unit circle. You got it memorized. So that would be great too. So let's go ahead and get our answer. And again, you want to make sure if you use the calculator and you're not going to the unit circle, you want to make sure you're in radians. If you do go to the unit circle, that's fine too. Or if you got it memorized, that is fantastic. Okay, so I get a negative square root of 2/2 for the sine value. Cosine at 7 pi 4ths, I get square root of 2/2, which if you see 4 in the denominator, you know, of the unit circle, we usually get the square root of 2/2. Just depending on what quadrant falls on, if it's negative or not. So I got this negative here times this positive, so it's -2 square root of 2 over 2. Oh, what can I do? I can put a 1 in the denominator here, and notice that my 2's reduce, right? So minus my 8 square root of 2 over 2. And again, I put a 1 underneath my 8 here, and we're multiplying, so the 8 and 2's reduce. So now what am I left with? Negative square root of 2 minus 4 square root of 2. Let's double check, make sure that I didn't leave anything out. The formula said 8 and 2 here. And then if you're ever in doubt of your answer, we know we can just type it in. I'm confident with my answer. I just like to double check sometimes, just to make sure I agree with what I have. And, oh, we're just not done. This actually cleans up better. Because if you look at it, they're like terms. So I have a -1 square root of 2 minus 4 square root of 2. So my end answer should be a -5 square root of 2. And that's my answer. That ends this section.